The electrical contractor's questions and the inspector's responses highlight code violations. The electrical contractor proposed using the bare conductor as a traveler or neutral wire, which is strictly prohibited by the National Electrical Code. Using bare conductors as a traveler or neutral could result in electrical shocks, fires, or other hazardous conditions. Inspectors are responsible for ensuring that electrical installations comply with the National Electrical Code, which sets minimum standards for safety and reliability. The electrical contractor's questions indicate a lack of understanding of basic electrical principles and code requirements. The electrical contractor has a license but did not take an accredited test, raising concerns about the quality of his electrical knowledge and skills. The inspector's responses were appropriate, refusing to approve the use of bare conductors for safety reasons, citing the National Electrical Code as the basis for the refusal, explaining the potential consequences of violating code requirements. The electrical contractor's resistance to the inspector's guidance is concerning. It indicates a disregard for safety and code compliance and may put the public at risk. Despite the situation, the inspector acted professionally. He remained respectful and provided clear explanations. He referred to the National Electrical Code as the authority. He provided additional guidance to educate the electrical contractor. However, the inspector's hands may be tied. The city's existing licensing ordinances allow individuals who did not take an accredited test to obtain licenses. This limits the inspector's ability to prevent unqualified individuals from performing electrical work. The city should strengthen its licensing requirements to mandate accredited testing for all electrical licenses. Inspectors should continue to educate and enforce code compliance to minimize electrical hazards. The electrical contractor should consider taking an accredited electrical course to improve his knowledge and skills. It is essential to understand that a bare conductor cannot be used as a neutral or traveler wire in the standard electrical circuit. This is primarily due to safety concerns and the requirements outlined in the National Electrical Code. Firstly, electrical shock is a significant hazard. Neutral wires typically carry current back to the source and are generally kept at or near ground potential. Traveler wires are used in 3-way and 4-way switch circuits. If a bare conductor is used for either of these purposes, it presents a direct contact hazard. Anyone touching the wire could receive a dangerous electrical shock, especially if the wire is not properly grounded or insulated from conductive materials. Secondly, short circuits and fire hazards are concerns. A bare conductor is more susceptible to accidental contact with other conductive materials such as metal boxes, pipes, or other wires. This contact can create a short circuit, leading to a surge of current that can overheat wires and potentially start a fire. In typical residential or commercial electrical systems, conductors are insulated to prevent such unintended contacts. Thirdly, there are National Electrical Code requirements. The National Electrical Code sets standards for safe electrical installations. Section 310.15 B3 addresses conductor types and insulation requirements. It mandates that conductors must be properly insulated unless specifically permitted otherwise. Using a bare conductor as a neutral or traveler wire violates these insulation requirements, making the installation non-compliant and unsafe. Fourthly, grounding and bonding are important considerations. While grounding conductors can sometimes be bare, they serve a specific purpose of providing a low impedance path for fault current to return to the source, thereby tripping a circuit breaker or fuse. Neutral conductors and traveler wires do not serve this grounding function. Using a bare conductor for these wires can compromise the grounding and bonding system, reducing its effectiveness in preventing electrical hazards. Fifthly, identification of conductors is crucial. Insulated wires are typically color-coded to indicate their functions, such as black for hot, white for neutral, and green for ground. This color coding helps electricians and inspectors easily identify the purpose of each wire. Using a bare conductor eliminates this visual identification, making it difficult to trace circuits and troubleshoot problems. This lack of identification can lead to errors during maintenance or future modifications to the electrical system. Sixthly, consider the potential for corrosion and degradation. Bare conductors are exposed to environmental factors such as moisture, chemicals, and physical abrasion. This exposure can cause corrosion, which increases the resistance of the conductor and reduces its current carrying capacity. Over time, this degradation can lead to overheating, voltage drops, and even complete failure of the circuit. Insulated conductors are protected from these environmental factors, ensuring a longer lifespan and more reliable performance. Seventhly, the integrity of the electrical system is important. Using approved wiring methods and materials ensures the overall integrity and reliability of the electrical system. Substituting a bare conductor for an insulated wire undermines this integrity and can create a weak point in the system. This can lead to a cascade of problems affecting the performance and safety of other connected circuits and equipment. Eighthly, consider the legal and liability aspects. Electrical installations must comply with local codes and regulations, which are typically based on the National Electrical Code. Violating these codes can result in fines, penalties, and legal liability in the event of an accident or injury. Using a bare conductor contrary to code requirements demonstrates negligence and can expose the installer or property owner to significant legal risks. Ninthly, professional standards should be upheld. Licensed electricians and electrical contractors are expected to adhere to professional standards of workmanship and safety. These standards include following the National Electrical Code, using approved materials, and employing safe installation practices. Deviating from these standards by using a bare conductor reflects poorly on the electrician's competence and can damage their reputation. Tenthly, education and training are essential for all professionals. Continuous education and training are crucial for staying up to date on the latest code requirements, technologies, and safety practices. Electrical contractors and inspectors should invest in ongoing professional development to ensure they have the knowledge and skills necessary to perform their job safely and effectively. This includes understanding the reasons behind code requirements and the potential consequences of violating them. In summary, using a bare conductor as a neutral or traveler wire is unsafe, non-compliant, and unprofessional. It poses significant risks of electrical shock, fire, and system failure. Licensed electricians and inspectors must understand and adhere to the National Electrical Code to ensure the safety and reliability of electrical installations. Continuous education and training are essential for maintaining competence and upholding professional standards. Additional information includes understanding the purpose of neutral conductors, which is to provide a return path for current in an alternating current circuit. The neutral conductor is typically connected to ground at the service entrance, which helps to maintain a stable voltage and reduce the risk of electric shock. In contrast, traveler wires are used in 3-way and 4-way switch circuits to allow a light or other electrical device to be controlled from multiple locations. These wires carry current between the switches, but they are not intended to be grounded or used as neutral conductors. The National Electrical Code specifies the types of conductors that are permitted for use as neutral and traveler wires. Typically, these conductors must be insulated and identified with specific colors, such as white for neutral and red or black for traveler wires. The code also specifies the minimum size and ampacity of conductors, depending on the load they are expected to carry. Ignoring these requirements can lead to overheating, voltage drops, and other problems. Proper grounding and bonding are also essential for safety. Grounding provides a path for fault current to return to the source, which helps to trip a circuit breaker or fuse and prevent electric shock. Bonding connects all metal parts of the electrical system together, which helps to equalize voltage and reduce the risk of shock. The National Electrical Code specifies the methods and materials that must be used for grounding and bonding. These requirements must be followed carefully to ensure the safety of the electrical system. The electrical inspectors play a critical role in enforcing the National Electrical Code and ensuring that electrical installations are safe and compliant. Inspectors review plans, conduct inspections, and issue permits to ensure that electrical work is done correctly. They also investigate complaints and take enforcement action against those who violate the code. To be effective, electrical inspectors must have a thorough understanding of the National Electrical Code and the principles of electrical safety. They must also be able to communicate effectively with electricians, contractors, and homeowners to explain code requirements and resolve disputes. Licensing of electrical contractors helps to ensure that they have the knowledge and skills necessary to perform electrical work safely. Licensing requirements typically include passing an exam, completing an apprenticeship, and obtaining insurance. Continuing education is also often required to keep licenses current. Licensing helps to protect the public from unqualified or unscrupulous contractors. However, licensing alone is not enough to ensure safety. The electrical contractors must also adhere to ethical standards, follow the National Electrical Code, and use safe work practices. They must also be willing to learn and adapt to new technologies and code requirements. Homeowners and business owners also have a responsibility to ensure that electrical work is done safely. They should hire licensed contractors, obtain permits, and follow the National Electrical Code. They should also be aware of the signs of electrical problems, such as flickering lights, sparking outlets, and hot wires. If they suspect a problem, they should contact a qualified electrician immediately. In summary, electrical safety is a shared responsibility. Electrical contractors, inspectors, homeowners, and business owners all have a role to play in ensuring that electrical installations are safe and compliant. By following the National Electrical Code, using safe work practices, and staying informed about electrical safety, we can all help to prevent electrical accidents and injuries. Also to note, the National Electrical Code Section 310.10 states that insulated conductors are required for most applications to ensure safety and prevent electrical hazards. There are very limited exceptions where bare conductors are permitted, such as for grounding electrode conductors under specific conditions, but these exceptions do not apply to neutral or traveler wires. For grounding electrode conductors, the National Electrical Code permits bare conductors under certain conditions because these conductors are intended to provide a direct path to ground for fault currents, minimizing the risk of electrical shock. However, the requirements for grounding electrode conductors are very specific and do not apply to other types of conductors in the electrical system. It is also critical to consider the specific requirements for conductor identification. The National Electrical Code requires that neutral conductors be identified by a white or grey color, while ungrounded conductors such as hot wires and traveler wires must be identified by different colors such as black, red, or blue. This color coding helps to ensure that electricians can easily identify the purpose of each conductor and avoid making dangerous mistakes. Using a bare conductor for a neutral or traveler wire would violate these identification requirements and increase the risk of electrical hazards. Furthermore, the use of a bare conductor can compromise the insulation coordination of the electrical system. Insulation coordination refers to the process of selecting and coordinating the insulation levels of different components in the electrical system to ensure that they can withstand the expected voltage stresses. If a bare conductor is used, it can reduce the overall insulation level of the system and increase the risk of insulation breakdown and electrical faults. This is particularly important in modern electrical systems, which often include sensitive electronic equipment that can be damaged by voltage surges or other electrical disturbances. Additional considerations include the potential for electromagnetic interference. Bare conductors can radiate electromagnetic energy, which can interfere with the operation of nearby electronic devices. This is particularly problematic in commercial and industrial environments, where there may be a high density of electronic equipment. Insulated conductors help to contain electromagnetic energy and reduce the risk of interference. It is also important to consider the long-term reliability of the electrical system. Bare conductors are more susceptible to corrosion and other forms of degradation, which can reduce their current carrying capacity and increase the risk of failure. Insulated conductors are protected from these environmental factors and are more likely to provide reliable performance over the long term. In addition to the National Electrical Code, there may be local codes and regulations that further restrict the use of bare conductors. Electrical contractors and inspectors should be familiar with all applicable codes and regulations to ensure that electrical installations are safe and compliant. The information provided is for general guidance only and should not be considered a substitute for professional advice. Electrical work should only be performed by qualified electricians who are familiar with the National Electrical Code and other applicable codes and regulations. Always consult with a qualified electrician or electrical inspector before making any changes to your electrical system. The question also mentions ceiling fan installation. Mounting a ceiling fan directly to a joist without a proper electrical box is a safety hazard and a violation of the National Electrical Code. The electrical box provides a secure and fire-rated enclosure for the wire connections. It protects the wires from damage and prevents them from coming into contact with combustible materials. Section 314.27 C of the National Electrical Code specifically addresses the requirements for supporting ceiling fans. It states that ceiling fans must be supported by a listed outlet box or outlet box system that is identified for fan support. The outlet box or outlet box system must be able to support the weight of the fan and any additional loads that may be imposed on it, such as from light fixtures or accessories. Mounting a ceiling fan directly to a joist without an electrical box can create a number of hazards. The wires can become pinched or damaged, which can lead to short circuits or electrical fires. The fan can also come loose and fall, which can cause serious injury or property damage. In addition, the absence of an electrical box can make it difficult to properly ground the fan, which can increase the risk of electric shock. The canopy of a ceiling fan is not designed to provide a secure and fire-rated enclosure for the wire connections. It is only intended to conceal the wires and provide a finished appearance. Trying to use the canopy to hide the wires without an electrical box is a shortcut that can have serious consequences. Electrical inspectors are responsible for ensuring that ceiling fans are installed safely and in accordance with the National Electrical Code. They will typically require that ceiling fans be supported by a listed outlet box or outlet box system that is identified for fan support. They may also require that the electrical box be properly grounded and that the wire connections be made in a safe and workmanlike manner. The electrical contractor's resistance to using an electrical box for ceiling fan installation suggests a lack of understanding of basic electrical safety principles. It is important for electrical contractors to stay up to date on the latest code requirements and to follow safe work practices at all times. This includes using the proper materials and methods for all electrical installations, including ceiling fans. Homeowners and business owners should also be aware of the requirements for ceiling fan installation. They should hire licensed electrical contractors to install their ceiling fans and should ensure that the installation is done in accordance with the National Electrical Code. They should also inspect their ceiling fans periodically to ensure that they are properly supported and that the wire connections are secure. The National Electrical Code Section 314.16 specifies the requirements for the size of electrical boxes. The size of the box must be large enough to accommodate all of the wires, devices, and connectors that will be installed in it. The code provides formulas for calculating the minimum size of the box based on the number and size of the conductors. Using an undersized electrical box can create a number of hazards. The wires can become overcrowded, which can lead to overheating and short circuits. It can also be difficult to make proper connections, which can increase the risk of loose connections and electrical fires. In addition, an undersized electrical box may not be able to provide adequate support for the devices and connectors that are installed in it. The National Electrical Code Section 110.3 B requires that all electrical equipment be installed in accordance with its listing and labeling. This means that the equipment must be used in the manner for which it was designed and tested. Using electrical equipment in a manner that is not in accordance with its listing and labeling can create a number of hazards. For example, using an outlet box that is not rated for fan support to support a ceiling fan can lead to the fan falling and causing injury or property damage. Similarly, using an undersized electrical box can lead to overheating and short circuits. It is important for electrical contractors and inspectors to be familiar with the listing and labeling requirements for all electrical equipment. They should also ensure that all equipment is installed in accordance with these requirements. In addition to the National Electrical Code, there may be local codes and regulations that further restrict the installation of electrical equipment. Electrical contractors and inspectors should be familiar with all applicable codes and regulations to ensure that electrical installations are safe and compliant. The electrical contractor also needs additional education to improve his understanding of electrical safety and code requirements. The inspector should have the authority to require the electrical contractor to take continuing education courses to address his knowledge gaps. This would help to ensure that the electrical contractor is able to perform electrical work safely and in compliance with the National Electrical Code.